Okay, time for week 4. Yay! Lecturing in space to myself. Always fun. Okay, so we're going to do logical beginnings. Hopefully the logic problem kind of primed you a little bit for Boolean logic, because that's what we're going to be using today. Now, a large portion of this particular PowerPoint, especially all the symbols, is on the final. So do pay special attention. This is where programming gets to start feeling program-y. Okay, so we have 17 slides today. Basic math and logical operators, nesting, a whole bunch of examples, and the snippets you're going to need for this week's assignment. Let's start with mathematical operators. So the term expression just means math problem. When we're using math problems in programming, we're going to use the same icons that we would use if we were doing math in spreadsheets. If you haven't taken spreadsheets yet, you will. So we've got a slash for division, an asterisk for multiplication, plus and minus are nice and easy. And we've got a percent sign for modulus. So modulus is the remainder when you have a division problem with whole numbers. So in the case of 12 divided by 5, the answer is 2. And the modulus is also 2. It's the remainder. I can't really think of a good place to use this. The best example I can come up with is if you're playing a game with inventory stacks, something like ammunition or something where you're doing crafting, like Don't Starve, and you have like 55 pieces of wood and you can put 10 per slot. You'll put, 10 in one stack, 10 in another, 10 in another, 10 in another, etc. And the modulus, the leftovers they end up in the last inventory slot. And that's the best example I can come up with for this. I know it has a use, but I've never needed it. But it's good to know. Okay, so next we have shorthand. This is where programming starts to feel program-y. We have plus plus. Plus plus is to increment by 1. It's basically the same thing as taking any sort of variable like HP and then adding 1 to it. You're going to see it a lot when we do things like loops. Every time we loop around, loop counter plus plus. You can see it for extra lives. It's just a really easy way to add 1. Now, everyone's probably heard of the programming language called C. Then there's C++. Ta-da! Now you know it's the next increment of C. It's C plus 1. Just a little trivia on that. So C# is C4, and it's based on musical theory. Someone who knows more musical stuff can probably explain that better, but the sharp is representing 4. Next we have decrement by 1. So minus minus removes 1 from whatever variable we have. Good things are like timers, countdown timers, timer, and then you put on a loop, timer minus minus. The loop runs, starts over, timer minus minus, loop runs, starts over, minus minus. And again, it's the same thing as writing timer equals the value of timer minus 1. Then you run it again with a new value. We have combined operators, plus equals, minus equals, multiply, divide, and modulus. So this performs a calculation and then reassigns the number to the variable. So doing x plus equals y is the same as writing x equals x plus y. Now put it into game terms, it's a little easier to digest. So if we have a variable for hit points minus equals fire damage is the same as saying the hit point variable equals the hit point variable with fire damage subtracted. Okay, so all this on the final. All this on the final. Okay, so next we have logical operators. So when we're doing conditional execution, we need to ask a question. We need to ask, is this true? Is it true that this is more than this? Is it true that it's not true? So every time we have this parentheses in an if statement, every time we're asking a question, it needs to be answered by true or false. So that's kind of why we do the logic problem, get you sort of in Boolean logic mode, okay? So the parentheses have to evaluate to a true or false. And we can do crazy stuff. We can say, is it true that this is not true? Is it true that this is true and true that that's not true? We'll pull up a little text pad and look at some of these options too. So we have symbols. You should remember from elementary school, little alligators, greater than or less than. Greater than or equal to, less than or equal to. So these are important. If you have something where you say, if it's greater than 5, do this. If it's less than 5, do this. You've missed the condition for what if it is 5. So having the greater than or equal to, less than or equal to is something you want to do quite frequently. Next we have the and the or operators. And I'm going to go ahead and I'm going to throw a text pad on the screen so we can talk about how ridiculously complicated we can make this. And it's 2 ampersands. There is different meanings for single ones, so you always want to use the 2. Means both conditions have to be true. So this is one of those things where I want you to occasionally talk it out to yourself, and I know that seems stupid, but if we have if A and B, right? Apparently this makes my computer super slow. So in this condition, A and B have to be true in order for our instructions to run, right? But we also have or. Or is double pipes. So A, it's above your enter key if you need to find it on your keyboard. Okay. A or B. So in this case, only one of them has to be true for the instructions to run. But we can do really ridiculous stuff with this. We can say, let's see, A and B and C and D, okay? So all of those have to be true, right? Or A and Q or P, okay? So we can ask, this is legitimate, I swear. So we can ask these ridiculous combinations of questions to test a whole bunch of conditions. So if A and B and C and D are true, and how you kind of evaluate this, if this is true, and this is true, and this is true, and this is true, then this is all true, okay? Or we can say A and Q, okay? If they're both true, then it's true. If one of them's true and the other one's false, then this evaluates to false. And then we have just this one down here, and then we can say, let's just say true. But because we started with true, when it's an or, we already know this entire statement evaluates to true, because we only need one of them to be true for it to evaluate. Okay, so I know that was kind of a little off the wall there. But when we have ands, everything has to be true. When we have or, only one thing has to be true for the instructions to run, for the condition to be satisfied. Okay. Next, and again, I'm going to mention, every part of this is on the final. Okay. So we have, we're going to be checking if 2 things are the same quite a bit. So we can't use equal sign because we use equal to assign a value, right? So we use equal sign like here, HP equals 5. So if we want to ask if something's true, we're going to do, is it true that hit points equal 0? Is it true that hit points are less than or equal to 0? Okay. Is it true that player name dot string equals Bob? Okay. So equals is to check if 2 things are the same. If it's true that they are equal to each other. We have another operator though. We can say, is it true that player does not equal Bob? Okay. So is it true that this is false, that these things are not equal? Okay. So there's all sorts of ways we can ask questions. Since we only can ask true or false questions, we have a whole bunch of sneaky ways to get the answers we want out of it, and that's using all these logical operator symbols. The exclamation mark by itself is pretty much not, so it's really equal. Oh my god, not equal. Remember this. It's the oh my god, not equal sign. And then an exclamation mark is not, so there's going to be times where we actually just ask for something to be not something else. Okay, moving on. So another thing you have to realize is when we're asking questions, when we're asking these true-false questions, we cannot compare apples and oranges. We have to compare apples and apples, oranges and oranges, motorcycles to motorcycles. So they have to be the same type for us to compare. So I can compare int hit point and int mana point. Yes, you can compare ints and floats. I can compare game object to game object. But I can't compare or add and assign to each other game object to hit point, because these are different things that won't know what's going on. Okay. A big mistake people do often is you want to ask if a game object is equal to a word, but you can't check a game object in a string. You can, however, find the name that is attached to that game object, because that's a string, and ask if it's equal to a string. So these are all valid. We can check GameObject.name equals this string. Int is greater than or equal to that int, or Boolean is not equal to true. Okay, so there are all sorts of sneaky ways to ask questions. Brief talk about nesting. I'm not really going to go over the slide so much anymore. It used to be a nice way to show you how nesting looked in Alice, which used to be the program we used until I took over this class and decided we're going to use real software. Now I just leave it there so you can be happy we use Unity. Okay, next, nesting. So this is not good syntax necessarily. It is me arranging it in a way to teach you things. So we have update, and nesting is just taking a code and putting it in another code, okay? Now you cannot put a function in a function, but you can put an if statement in an if statement. There's nothing special about it. All what you're doing is just making the instructions for an if be an if, okay? So there's going to be several times where we're going to do this, actually, and a ton on the week 4 homework. So what's going on really is we need a condition to be satisfied before we even care about looking at other conditions. So think about something like, have you named your character yet? If you don't want the game to be playable until the character is named, you can put all the instructions for that game into an if statement checking if the character has a name. Or you might have a game that says, if the player is alive, then do these instructions. And these instructions go, check if we're pushing up to move forward, check if we're pushing left to move left, check if we're pushing A to fire. But there's no point in checking all those conditions if the player's dead, right? So it's a one-way. We could also say if the player is alive and the A button is pushed. But then we have to do if the player is alive and the front button is pushed. If the player is alive and the B button is pushed. So it's a way of consolidating a whole bunch of if statements that are conditional on another condition. So here we have, if Lancelot is in the forest, do this thing. This thing is going to be check if the beacon's on. If he's in the forest and the beacon's on, do these instructions. Now we also have else. Else is going to run when this condition fails. So no matter how many conditions we put, it will go through it sequentially. And if nothing gets triggered, it'll just do this one. This is the end all if everything else fails instruction. Once it triggers one of these though, if this triggers, it does not bother to check any other conditions. So do keep that in mind. So if Lancelot is not in the forest, if Lancelot in the forest equals false, we go right down to the else. Let's look at more combinations. Okay. So if the weather is not raining, run around in your underwear. Okay. So that's a single branch if statement. We have one condition and we have one thing that either gets executed or it doesn't. Now, just because it's not raining doesn't mean it's nice out, especially since we're in Oregon. Okay. Could be raining, could be a zombie apocalypse, whatever. We can check a second condition. If the weather's not raining, check if it's snowing. If it's not snowing, run around in your underwear. Okay, so another variation here. If it's true that the weather is gross, check if it's raining. If it's true that the weather is rain, get your umbrella. If it's gross, but it's not raining, put on pants. Okay? If it's not bad weather, run around in your underwear. Okay, more examples, because they're fun. I'm not going to do this when we do it in class live, but this is just to give you a series of conditions. So if we flip a coin and it's heads, we'll roll a dice. If we roll a dice and it's greater than 3, I win. If we roll dice and it's 3 or less, you win. If we flip the coin and we get tails, you escape. Okay, so just more examples of the different ways we can branch things. And as I said, you can branch these pretty much infinitely. Okay, and another quick slide on the different ways the math can work. So if you were a little confused on the plus equals, minus equals, my hit points minus equals fireball damage. So the code takes my hit points, we're going to make it arbitrarily 25, subtracts fireball damage, which is 5, and then reassigns it to hit points. So now the variable my hit points is equal to 20. Okay. A little bit more here. We have some snippets next, and that's the important part. Don't forget to read the PDFs. They're there for a reason, and they're there for you to refer to when you're doing your homework. So we've got methods or functions. You're going to hear these interchangeably for this class because we're using a object-oriented programming language. So it's a named section of a program that performs a specific task. Update, start, and today we're going to write something called enemy turn. All methods are functions, but the difference is a method is a function that is owned or associated with an object. In object-oriented programming, all our methods are associated with an object. So everything, or all our functions are. So all our functions are methods, all our methods are functions. As I said, you'll hear them used a little bit interchangeably. To give you a little bit of a breakdown on functions, we have the return type. So frequently this is how you write it. If you saw update here, you'd be used to it. The return type is what kind of information we have to get back out of the program. Now, we are generally not using return types for this class. We just don't happen to need them. But know that we can put things like int or game object or light or all sorts of cool things there and get it regurgitated out. Now, if we don't need anything, it still wants a return type, so we just put void. It's a null data type that returns nothing. Next, we need the name. So best function ever, right? Right. Make sure no spaces and camel caps are generally good use, so having each word be a capital. Next, we have to put a container. So sometimes we do need to put information into the function that it needs to run, but even when we don't, we add a container just in case. Then we have the curly braces. The curly braces are pretty important. They let us know what set of instructions are owned by what keyword and function. So when we have if statement, the information, the instructions between those curly braces tell us that those are used for that if statement. We also have curly braces for update, and then we even have curly braces encompassing our entire script. So it's really important that we have a start and end of the instructions signified to the computer. Then we also have code comments. We've kind of glossed over this so far. By putting these two little slashes here, we create a sentence that the computer ignores. So it's a really good way to write notes to yourself. I frequently start a project and put it down for a year. When you guys are turning in homework to me, you got to comment out your code. I'll sometimes give you specific information, but generally if I need to troubleshoot it, I need to know what you were trying to do, because it might accomplish a task. It's just not the task you want it to do. You also generally should comment code if you are leaving code for a few minutes. Let's say you're writing one thing in one area and you go to another area. It'll help you figure out where you are and what you're doing. Okay, so calling. This is one of these things that's really important for programming. So you can't make a function inside another function. It'll piss off your computer, it'll create an infinite loop, blah, blah, blah. So what you do is you write any code, especially if you're going to use it more than once, in a brand new function by doing void, name of the function, a container, and some curly brackets. When you want to use all those instructions, you don't have to rewrite everything. You just call that function. And all we have to do is write the name of the function, add a container, and throw a semicolon at the end because you're asking the computer to do something. So it'll go and it'll take all the instructions from that function and it'll do them when it sees this line. Then it'll just continue on the next line down your code. Okay, so random.range. I like adding randomness into games. I think it makes it fun. And today we are going to simulate some very sad artificial intelligence by rolling the dice to select rock, paper, and scissors for our competitor. So the way that we do this is we have a function that's built into the computer called random.range. So it's just going to pick a random number, but this is a computer we're talking about. If I look at you and I say, pick a random number, you're going to need a little more information to do that for me, right? You need to know what the minimum number is and what the maximum is. Because again, we're working with a computer. If I say, hey computer, pick a number, it'll be like, cool, I got one. It'll be like, is it 4,932? And it'll be like, no, guess again. Is it 7? No, guess again. Is it 4,007,900? So you need to give it a range. You need to clamp it down a little bit. So you need a minimum and a maximum. But here's the deal with our data types for this. If you're using a float, if you're using a decimal point, the maximum is included. So if you want to use a float to roll a 6-sided dice, your numbers are going to be 1 for minimum, 6 for maximum, but you're going to get a decimal back, don't forget. If you're using an int, the maximum is exclusive. So the roll can go up to that number, but it will not include that number. So if you're rolling a 6-sided dice with ints, you need 1 and 7, okay? It's not something you have to hard memorize. It's almost better to be in the habit, since you're going to use ints more often, just to get in the habit of adding that extra 1 onto the maximum. Okay, last slide. So with the haunted house, we turned lights on and off with dot enabled. We can take an object and hide it completely in the scene. We're going to deactivate it. So what we have is dot set active, and in the parentheses, we provide a true or false and a semicolon. So if we want something to be gone, we're going to do the object name or variable dot set active, and false will make it disappear. If we want it to turn back on, dot set active equals true. Ta-da! And that's how we turn things on and off. So we're going to be hiding things in our rock, paper, sword activity today. So we can have the objects appear as we roll the dice, compare, and then give a point value based on it. Okay? There you go.